So yes, good morning, all of you. Yeah, we are starting with this wireless sensor network part of Internet of Everything, and in the previous sessions we have seen uh, basics of WSN, then modes we have seen specifically. Then in the previous lecture, I actually gave demonstration about Node ESP8266, that is Node MCU, and how to configure that, how to attach that thing to system, then how to write a simple program, and then uh, how to run the program on that. You see, so these are the nodes that are building blocks of this WSN. So let us dive deeper, because in the uh, understanding of this IoE, these protocols which wireless sensor network use, how they transfer the data, how they communicate with each other, these are all important things. These are all important things. So yeah, here we are going a bit deeper in the WSN. So this will enable you to answer the questions that what are WSNs, how they are configured, what are the protocols used by WSNs, how they how they transfer the data from one point to other. So all these things are covered in this part. So WSN that we are going to discuss. Yeah. So this is the agenda. Yeah. What we are going to study. Let's move ahead. So wireless sensor network. In this previous one also we have seen a bit revision here. It is a deployment of nodes, and what are these nodes already we have studied in details of that. And these nodes have specific functionality is collectively. For example, environmental monitoring or the weather monitoring. If you monitoring you have, so every node will probe the environmental parameter, that is temperature, then humidity, then if environment barometric pressure is there, so for this, so BME 280, this sensor may be used. So all these nodes are there with specific, what you can say, a specific goal, and they collect the data, and then they upload. They are in communication with the base station. So this is now pure WSN concept. I told that WSN concept. Okay, so there might be one edge node which might be communicating on every node. So how they do this thing? So here these nodes may be deployed over no maybe 1 square kilometer, for example. Okay, 1 square kilometer or 1 square mile maybe, and then this base station is away for suppose 4 miles or for 10 maybe 7 kilometers. So how they are going to come in? All these things are there. These are the part of the discussion that we are going to have. Okay. So briefly, again, what it node consists of? Here we have seen that thing. So for example, not because this device is called as node MCU, it is used as node. As now this concept is a generic concept, legacy concept, I'll say, that has been used by network engineers to for environmental based project or field based projects. But with IoE for smart applications, for smart city applications, so we are having uh, this extension of WSN is there. So this is a what I can say a typical WSN node. So it has got its this compute and this IO system. Then it has got here you can see. I'll just show you that everything now I have. Yeah, yeah. So power system here you can see this portable chargeable battery, rechargeable battery. Then it has got this sensors. Here sensors can be seen. Then mobilizers here you can see here not seen. This transceivers. Here this transceiver is there. So IEEE transceiver. This processor and storage here. The processor and storage sensor. Here you can see sensor and ADC here on board. It has got its onboard ADC also. Then location finding system. It is I'll say that optional here in case of Node MCU, because it is not always we actually what you can say use GPS here. It is not like that. So some you may have this GPS what you can say base GPS based location finding system, or there is something called as ultra wideband communication. So ultra wideband communication, that is for low range. For example, for certain buildings, certain what you can say area where you will have ultra wideband based this transceivers, and using that, no, this system, you can precisely locate a person in the specific node. Or simple, if when these nodes are transmitting certain, data, the data, this data packet will have this ID, and this ID will indicate that which node has is sending the data. And if you have this deployment, suppose node 1, node 2, node 3, node 5, node 6, node 7, like this thing. So if this is ID, here you can say if this ID is suppose 1, then you come to know location is in the proper east corner of my building, kind of thing. Okay, east corner, first section. Okay, so some kind of location finding system is it. Then power unit, I am showing you this power unit is there. Power generator, so you may have solar power generator, you may have suppose this battery replacement kind of protocol, or some process you follow, that thing. And then the mobilizer in a way, how you are going to manage the movement of the node. So it is not, no, always you are going to maybe move this node may be part of the car, or part of some robot, or part of some vehicle, or part of some, so moving object maybe. So all that thing depends whether these nodes are static, or whether these nodes are moving. So for example, your smart car, and because these nodes which are fitted to this various part of engine, and then these vitals will be sent to the cloud. So how these things are, kind of this location finding system whether optional, but other things can be seen here. They are part of the typical node that we have discussed. Your node MCU in detail we have discussed in the previous lectures. Okay. Yeah. So characteristic of this uh, wireless sensor networks, WSN networks, now collection of this all such nodes, they will form network. And what are the characteristics of that network? So small size of the nodes, then nodes will come in large number. So here you can see now the size of this typical node. Even if you pack everything, like it will be something like this is Raspberry Pi, but something like that thing. So where battery will be there, then this node, this sensor, everything will fit in something like this, some case something like this. This can be one portable node using node MCU. Now it is Raspberry Pi, I'm just giving example. But even if Raspberry Pi is there, you can attach batteries and sensors here. This can be a small portable. Okay. Then beyond that, we have to deploy these nodes in very large number. So node MCU is a very good solution because it is low cost effective and tetherless and low cost concept. So here it has got its own, what you can say, communication system, and it can communicate with other devices with very minimal configuration. Okay. And low cost is there. Obviously this is costing $1 or $2. In India it costs around 250 to 300 rupees. Then it consumes very less energy. We have seen that it has almost 2.5 microampere of idle current in the range of this thing. 5 ampere to 2.5 microampere in the idle current is there. So very low power consumption. In case of this node 32, by default it has got BLE, Bluetooth Low Energy, and low idle currents. So this energy consumption is very low, and the communication systems are there. So this node MCU 80 this a, this node MCU has got its 802.1 BGN compatible communication system. So that can communicate on 2.4 gigahertz wireless band, and this can be one, what you can say, portable node. Then small size implements, small battery for the nodes, low cost energy, low power CPU. Tensilia CPU it had, 2 core CPU, and radio with minimum bandwidth and range. I discussed this 802.11b. Then there is concept called as ad hoc deployment. This detailing we'll see. This WSNs and ad hoc, what is the differences? This question may come. There are ad hoc WSNs are there, and ad hoc networks are there. So what is the difference between this wireless sensor network and ad hoc? So yes, sometimes these WSNs may be in ad hoc deployment mode. So what you can say that some nodes may come in, some nodes may go out, they may be moving. So very less maintenance, no maintenance or battery replacement, because as the battery is what you can say going down, the node will go out of service. So that should not impact overall operation of your WSN, wireless sensor network. Okay. And yes, so to increase the network lifetime, no raw data is transmitted. Rather, this data is gathered, formatted, noise is removed, and then in proper format, forward packets things, the data will be sent. So packet means the collection of data. This packet consists of what is the ID, then sensor, I mean the timestamp, and then the sensor data. So S1 data is sensor 1, sensor 2, sensor 3 data. So such packet will be built, and this packet will be transmitted by each nodes or maybe the gateway device. Okay. So ad hoc wireless network. This is another concept. Yeah. So what is this? It is a large number of self-organizing static or mobile nodes. Yeah, you can see that are possibly randomly deployed. So when we say that the smart city and smart cars are coming out, then people are having their smart watches and they are moving in and out of this wireless network. So they form kind of no ad hoc wireless network. But thing is that in pure sense they are not ad hoc because one common goal they are not what you can say following. So for example, for a Google map, so when you say that this is a road and for this section these vehicles are coming and going, so the information about this section is collected by the mobile devices which are coming in and going out, then coming in here and going out here by this thing. So for at this place, here you can see there is the Google is having this small local this network, this movement of which is monitored, and then Google says that okay, there is high congestion here. Oh, congestion here. So because now this how these mobile phones are moving, their sensor it is using to sense the movement of that thing. So and again these sensors, what is happening? All these mobile phones are connected to Google Cloud, and then the Google Cloud is getting the data. But now think of this thing. What happens now? You are having your own deployment here, maybe your college campus, and for this college campus, you are having all students no, mobile phones are there, and this student mobile phone is used to track maybe I don't know overall no population count, and then every student this attendance is also measured. So what will happen? This rather than using cloud-based service, what I am doing, I am having one gateway device at one end, and then this all nodes they will transmit the data. So on Wi-Fi. So this has got its own Wi-Fi link, not internet, but simply Wi-Fi communication, or I'll say that Bluetooth communication kind of thing. For example, it has not got a very big range. So maybe suppose this range is of 30 meters. So what will happen? This to send this node one, for example, to send data to this receiver, it will have to send through hops. There will be one application which will be collecting data, passing. So what happens when students have their movement? Depending on that, they will be forming ad hoc network. So some nodes will be coming in, going out. Then based on what location they are having, finding from this no nearby fixed nodes or kind of thing or node IDs, they will be actually relaying the data from one, and this node will be transmitting to nearest nodes, and then they will transmit, and accordingly this data will reach here. So kind of self-organizing. Even if some nodes go out of service or they are not having their Bluetooth connected, still the protocol which will be designed such that it will send the data from one node to other to the central connecting entity. So and these nodes will be randomly deployed, randomly moving for this local ad hoc network kind of thing. Okay. So nearest neighborhood communication is there. So if two nodes are there and I have to communicate with this receiver R. So I will send the data through this kind of route, and this is nearest neighborhood communication can be seen here. And then wireless connections, obviously because we are using Bluetooth or point to point Wi-Fi communication for sending or uploading this student related data. And connectivity depend on power levels and wedding your mobile phones, their charging level, their battery level, depending on that what you can say. And then it will communicate. Dependence is high for omnidirectional antennas. So because this mobile phone these your nodes, they will be sending data to all nearby nodes. Okay, and then again they will be receiving by the all nearby nodes. Okay, so that is this omnidirectional what you can say, uh, transmission and reception will be there. So sensor networks and sensor actuators, this will see later on. As of now, ad hoc networks. So uh, WSNs and ad hoc networks, what are the differences? So this question will come, what is wireless sensor network and ad hoc network, and what is the difference between that? Difference. Okay. So both of them, they are self-organizing and infrastructure less, means what, you can simply freely in your premises, if either it can be static or dynamic. In case of it is dynamic, like this IoE deployment, then they are having some kind of self-organizing infrastructure, or infrastructure list, means no fixed location for that node is by default required. But what is the difference between both of them? Have this thing, nodes are there, and they are actually no kind of no free floated kind of thing as far as the communication and architecture is considered. Okay. So self organized into an infrastructure less network. But what is the difference? Okay. uh, Wireless network have got sensing and data processing. These are the essential things. So they will sense the environment and they will collect the data, gather the data, process the data. Then as far as deployment is considered, suppose we want to what you can say, measure the temperature over area, maybe there's some small colony. Here we are in colony, so you will have no nodes uniformly deployed over this thing, so that uniform readings are there taken. So WSNs are densely deployed. Okay. And we need large number of nodes here in case of WSNs. So they need what you can say, cost effective, these nodes are required. Okay. And in case even if this node fails, the network should continue to operate. So these nodes are what you can say, networks are robust enough, because their failure rate is high. And this needs no this, because there is something called as concept called as MTBF, mean time between failure. And generally for a typical device, 1000 hours to 5000 hours is a typical number. This is not hard and fast. But when you say that there are 10,000 nodes in my WSN deployment, so at any given point of time, 1 to 10 nodes are bound to fail. And even if such nodes are failing, your network must be operation. So these networks, because of large numbers, they are prone to failure, and they must operate under these conditions. And beyond that, as these nodes are highly portable and remote, they must have strict energy constraint. In case of ad hoc network, these nodes are mobile. They node will be coming, and networks, this node come in, move smartly, and because of that thing, they are now what can be said, that this the object which are which they on to which this they are forming this ad hoc network, we can have this compute high, then we can have good battery for this mobile nodes, and high, so what you can say, lifespan is expected when ad hoc networks are there. Okay. So and that's why these ad hoc networks, typically they are mobile, because their infrastructure have lots of change. But in case of WSN, typically they are static, sensor nodes, sensor deployment, because we have generated the node WSN architecture for a specific goal. Okay. So, but in IoE, when we say that Internet of Everything and context with IoE, then WSNs may have dynamic nature also. WSNs may have dynamic nature also in context of your Internet of Everything, IoT deployment, smart city application kind of thing. Okay. And in case of WSN, the communication is many to one. So here we are having the sensors using publish and subscribe model. So it is kind of many to one kind of communication also only. So there is one this central node, and then there are these sensor nodes are there. So all these nodes will be subscribed, and then these nodes will publish the sensor data, and they will keep on pushing the data. So pub sub model is there. So this is an example of many to one communication rather than peer to peer. Peer to peer communication is mainly in ad hoc networks, but depends on both. So here for this IoE pub subscript, that is many to one communication, is more what you can say suitable. In case of we simply want to pass on the data, then that relay kind of communication, there you will have to go for peer to peer also. And by default, what you can say it is, for suppose in a room, for a home, we want to go for smart home, then it will be many to one communication will be there, because I will have my sensors in various rooms, and to central using central Wi-Fi, they will be communicating with the central node. So that is many to one communication. But when I say that I want to deploy the movement detection system on my college campus, then we have to go for hop based communication. And maybe all nodes transmitting their data to central what you can say server or central edge device or this edge device, but the communication will be through peer to peer communication kind of thing. So connect the packet, relay the packet, table, there will be tables, these things will be there. So these concepts are quite fundamental. You should understand where now, because of this IoT, because of this IoE, and application wise, you may have to go for different architecture. Yeah. Then when it comes to lifetime, these nodes are battery power for both, mainly for ad hocs and WSN. But WSN deployments are on bigger area. So even in case of IoE deployment, when I say WSN deployment, first choice for the deployments are IoE or IoT smart city applications. So these nodes are battery powered and they should be highly optimized. Okay, so that's why here the last sentence. Nobody is going to change the battery on the frequent basis. So operation, so whenever you perform certain operation, the battery consumption increases, and that will result in the node go out of service if the battery fails or battery dies down. So we have to have some measures either to replace battery or charge the battery on the go, because changing 10,000 batteries maybe every couple of months is a very big task. So that battery life is very crucial here. So that's why to save energy, what these nodes do in WSN, they sleep as much as possible and acquire data only if it is indispensable. Meaning they will not keep probing every minute or every second. Rather, every 30 minutes, every hour, they will take the data reading, and then they will gather the readings, and maybe after at the end of the day they may upload the data kind of thing. In case of real-time applications are not there, if you have a real-time application, then accordingly things can be configured. Okay, so use data fusion and compression, because they will save the packet size and number of packets to be transmitted from one point to other, and transmit and receive whenever necessary. Okay, so because this transmit and receive needs this no modulator demodulator to function, and it takes no energy, and we have to limit this thing as far as possible. So when these programmers, now you are all IT people here, when the programmers are writing application, when it means you are writing your program on this node MCU, and so unnecessary writing instruction consumption and other things, that should be avoided. That should be avoided. The program should be as far as possible energy efficient. Should be, you must have battery optimized and energy efficient code has to be written. So we'll see this concept scalability, reliability, and then we'll stop. Okay. So scalability and reliability. What happens that we start a deployment with no initial, maybe for testing purpose, I will start with 10 nodes. So fine, and things are working fine. My protocols, my relay protocol working fine. So I increase this node network to 100. And as now these things are progressing, I may have to monitor a bigger area, and I say that now my deployment needs 1000 nodes. 1000 nodes. So this is an example of scalability. Your protocols, your edge devices, whatever device gateway devices, they should have capacity to manage this various number of nodes. So they should be scalable enough for uh, functionality purpose. Okay, and in case of this thing, if the node goes on increasing, so large number of nodes are there, so MTBF will increase. And if some node fails, still your network should be robust enough to carry out this data communication, maintain connectivity. Okay, then this base station, as they say, the base station, this data is uploaded from every node, so it should be reaching that base station with whatever the communication protocol that you are using. And that's why ensure the coverage, you are able to observe phenomena for all the nodes, all the area, when this number of nodes go on increasing. And suppose at one point you come to know that, okay, I need to change this program to make it more efficient or to read it properly, and then you will have to reprogram that. You will have to reprogram it. So how to go for reprogramming of the masses? Because now 1000 nodes, think of, you have to now flash new program. So for that purpose, we are using no uh, different packages, different program. This methodology, Puppet, Chef, and that kind of no this software orchestration kind of these technologies they use to know for updating large number of nodes at one go. So that kind of things they will come in the last module of this subject. Okay, so that's why it is highly desirable for this node to be reprogrammed wirelessly. So all these features, this your wireless node should be supporting, because collecting all the nodes and again connecting to the computer, programming that thing, flashing that thing, it is a very big task. It is a huge task. So that should be uh, wireless facility of that program should be programming that should be available. Okay, so yes, I stop here. If you have any doubt, you can put it on chat box, you can put it on the comment box, and maybe I will address that thing.